Welcome to The Explainer. So today, we're going to unpack the story of how React development has completely transformed over the last decade. We're going to follow the breadcrumbs all the way from these early patterns that, well, they kind of imitated old ideas, right up to the super innovative, server-aware architecture we're all talking about today.
All right, let's kick things off with a little piece of history. Take a look at this. If you've been working with React for a while, this whole React.create class thing is probably a serious blast from the past, right? But if you're new to the game, it might look, well, totally alien. And that's exactly the point. The story of why our code doesn't look like this anymore is pretty much the key to understanding everything about modern React.
Okay, so to really get a handle on where we are today, we've got to rewind all the way back to the beginning. When React first hit the scene, it was basically the Wild West. And developers, faced with this brand new thing, did what any of us would do. They grabbed the patterns and the tools they were already comfortable with, stuff from other languages and frameworks. So one of the first big ideas that everyone latched onto was the classic JavaScript module pattern. You have to remember, this was way before ES6 gave us our nice, clean import and export. Back then, this was the go-to move for creating private variables and just keeping your code organized. It worked using this neat trick called closures, which in simple terms are just functions that kind of remember the world they were created in. This allowed you to bundle up your code in these neat, tidy, encapsulated packages. The React team themselves even gave this a shot. They tried applying it directly, which led to these things called module pattern factories for components, but it just didn't work. It turns out this whole approach was constantly fighting against React's core ideas, its declarative nature, its life cycle. It was clunky, almost nobody used it, and eventually it was just so inefficient that it's been completely cut from React 19. Deprecated, gone.
So the big takeaway here is pretty simple. These patterns, which were pulled straight from classic object-oriented programming, they did not fit the very dynamic, fast-moving world of UI development. Seriously, instead of making life easier, they created a whole new set of headaches. Things like the infamous wrapper hell, I'm sure some of you remember that, where you'd have components nested inside components inside components. It was a mess. And you'd end up with these super brittle UI structures that would just shatter if you tried to change one tiny little thing.
And all that pain, all those headaches, it actually led to the first major mindset shift in the React community. It was this huge move away from inheritance and a full-on embrace of composition. And this, right here, just perfectly nails the core idea. Think about it. Inheritance is like a super rigid family tree. A component is a specific type of another component, and that's it. But composition, that's like building with Legos. A component simply has a bunch of other components inside it. And that simple switch in thinking is what lets us create these really flexible, loosely coupled UIs that are just so much easier to understand and, more importantly, to change down the road. One of the first really popular patterns to come out of this new thinking was the whole container/presentational pattern. And the idea was super simple, really. Separate your concerns. You'd have a smart container component whose only job was to handle all the logic, fetching data, managing state, and then it would pass all that data down to a dumb presentational component that didn't know anything. It just took the props and rendered the UI. Logic here, looks there. Simple.
Okay, but here's where it gets really interesting, how that idea has evolved. Today, we're still trying to get that exact same separation of concerns, but we do it so much more cleanly. Instead of having to wrap one component inside another, we just pull all that logic out and put it into a reusable custom hook. The component just calls the hook, gets the data it needs, and that's it. It's beautiful. No more wrapper hell.
And that, of course, brings us to the next massive evolution, hooks. When hooks dropped in React 16.8, it wasn't just some new feature. No way. It was a complete revolution in how we think about and write components. Hooks gave us the real building blocks we needed to finally fulfill the promise of those early patterns, but in a way that felt completely natural to React. So if you really squinted it, a custom hook is basically the true modern successor to that classic module pattern we talked about. It does the same thing. It encapsulates state and logic using closures, just like the old pattern did. But here's the magic trick. Instead of being a one-and-done singleton, it stores its state inside React's own internal machinery, in what's called a fiber node. And this is absolutely crucial because it means every single component that uses that hook gets its own fresh, independent managed state. So really, the takeaway here is super simple but incredibly powerful. If you're building a modern React app and you're thinking, how should I organize and reuse this piece of logic? Your first, second, and third thought should be custom hook. It is without a doubt the definitive pattern for encapsulation today. Okay, so custom hooks are great for our apps. But what if you're playing in the big leagues? What if you're not just building an app, but a truly reusable component library that tons of other developers are going to depend on? Well, that requires a whole new level of thinking about your architecture. You need to create APIs that aren't just powerful, but also incredibly flexible. The absolute key concept here is something called inversion of control. Now, I know it sounds like a fancy academic term, but it's really a simple idea. A great reusable component actually gives up some of its control to the developer who's using it. You let them take the wheel a little bit. And this is so powerful because it lets them customize its behavior in ways that you, the original author, might never have even imagined. And the compound components pattern is the perfect example of this in action. Instead of making someone pass in this giant, messy, rigid configuration object, you just let them build the component themselves from smaller pieces. This gives the developer total control over the layout, and it creates this beautifully clean, declarative API. It's exactly the same idea as how HTML's native select and option tags work together. It's genius. And if you want the absolute ultimate level of flexibility, you reach for the controlled props pattern. This is really considered the gold standard for library components because it gives the developer using your code a choice. They can either pass in props to fully control the component state from the outside, from the parent, or they can just let it be uncontrolled and let the component manage its own state internally. It really is the best of both worlds. All right, now let's jump to the really cutting-edge stuff. With the release of React 18, and now with 19 on the horizon, the very definition of what a React app is starting to change. The old clear lines we had between client-side logic and server-side logic, yeah, those are starting to get really, really blurry. So React 18 was this massive shift, mainly because it introduced concurrent rendering. At its core, this was all about one thing, making our apps feel faster and more responsive, even when they're doing some serious heavy lifting in the background. And to help us manage this, it gave us two super powerful new hooks. The first one is use transition. This lets you tell React, hey, this state update, it's not super urgent. You can mark it as low priority, which is amazing for keeping your UI snappy during something like a complex page navigation. Then there's use deferred value. This is for when you need to delay a re-render based on a value you don't actually control, like a prop that's coming in. It is absolutely fantastic for things like a live search input, making it feel perfectly smooth and completely non-blocking for the user. And now with React 19, we're getting the use optimistic hook. And honestly, this is a total game changer for user experience. It lets you update the UI instantly with what you think the state is going to be, a predicted state. This makes your app feel lightning fast. And then while the real server action is happening in the background, React will just automatically handle syncing up the final correct state when it comes back. It's magic. And all of this ties into probably the single biggest shift in modern React, server actions. This is a whole new way of thinking. You can literally define a function that runs securely on the server, but then you call it from your client-side component like it's just any other local function. This makes things like form submissions and data mutations so much simpler. It just cuts out a huge amount of boilerplate and client-side code we used to have to write. So to wrap it all up, what does the toolkit for a top-tier React developer look like heading into 2025? Well, it looks like this. We treat custom hooks as our #1 tool for reusing logic. We build flexible, library-grade APIs using compound components. We embrace server actions to make data changes way simpler. We use transition to keep our UIs feeling fast, and we remember to push state to the URL or server state libraries first, before reaching for client-side state. So yeah, it has been a pretty fascinating journey, right? All the way from simple imitation to real, groundbreaking innovation. The patterns we use are always a reflection of the problems we're trying to solve at the time. And as you can see, those patterns are always evolving. So the crucial takeaway, the thing to really remember, is that this story isn't over. The patterns have evolved. The real question is, how will your architecture? Thanks for watching.